my name is Wendy Reed and we're going to learn a little bit about similar triangles today. Similar triangles are triangles that are not exactly congruent, but they are the same in some ways, but not in every way. So we're going to start with the first way, and that's angle-angle similarity. Okay? Well, let's say we have two triangles. Okay? And I know that I have at least two pair of angles congruent. Okay? Here's one pair of angles being congruent, and here's the second pair of angles being congruent. Now, congruent means the same or equal. Okay? Now, if I have at least two, you can't have all three, but you really only need two, then I automatically know that these triangles are similar by angle-angle similarity. And by the way, our symbol for similar is just a squiggly line. So if you see this little squiggly line, that means similar triangles or similarity. All right, so let's put some letters on here. You have a triangle similarity statement, just like a triangle congruent statement. The only difference is the symbol. Okay, so if I say that triangle ABC is similar to triangle, the order of the letters does matter. If I do A, B, C, then I have to do D, E, F. Okay, so that means the triangles are similar. That's angle-angle similarity. That's actually the easiest one, so not a lot of going on there, but when we get to the second one, it will be harder. Let's do one more angle-angle just to show you a little trick. Sometimes the angles are not turned in the same direction, but they can still be similar whether they are or not. So let's say I have something like this. Okay, one of them's a little bigger than the other one, which is fine. They're not completely congruent or anything. But I already have this. Now, as you can see, the triangles are not turned the same way, but you've got an angle here and another pair here. Therefore, it is angle-angle similarity, so the triangles are similar. Now, when you do your triangle similarity statement, it's a little tricky because the triangles are not turned the same way. So you got triangle, we'll do HGI is similar to triangle. Now we started with the 1, then we went to the 2, then we went to the none. So we're going to do it on the same side. Start with the 1, L, go to the 2, K, and then the none, that's J. So the triangles do not have to be turned the same way, but they can still be similar. Alright, so that's angle-angle similarity. Let's look at side-side-side similarity. Okay, for side-side-side similarity, all three sides are not congruent, but they are proportional. And what proportion means, write that definition. The word proportional means that the ratios are equal. Now, another word for ratio is just fraction. So let's just replace that with the word fraction. So basically what a proportion is, or what proportional means, is that the fractions are equal. Okay? So let's look at an example. Now, it's very obvious that these two triangles are not congruent, simply because the segments are not congruent. So obviously the segments are congruent, the triangles are not congruent. But you don't need the sides to be congruent, you need them to be proportional. So what we have to check is to see if all the fractions are equal. So if I do 6 over 12, these two sides go together. So if I do 6 over 12, it has to be equal to the other two fractions. The second would be 7 over 14. The third one would have to be 8 over 16. So in order to find out if the triangles are similar, these all have to be equal. Okay? If you think about it, 6 over 12 is 1/2. 7 over 14 is 1/2. And 8 over 16 is also 1/2. Are those fractions equal? Yes, they are. Therefore, it is side, side, side similarity. So again, the sides do not have to be congruent, they have to be proportional in order for the triangles to be similar. And that's side, side, side similarity. Our last one kind of mixes these two up, and that's side, angle, side similarity. Now again, the sides are proportional, but the angles, just like in the first one, are actually going to end up being congruent. Okay? So let's say I have something like this. That's not going to work. Scratch that. Let's just separate them. Alright, let's look at this. Now it's obvious that you have a congruent angle because they're both right angles. So we have the A part. The angles have to be congruent, but the sides have to be proportional. And it has to be the included angle, which means this angle has to be between the two proportional sides. Okay? So let's check something. If I do 3 over 16, is that going to be equal to 4 over 12? Actually, no. 3 over 16 is not 1/3, because 3 over 16 does not reduce, and 4 over 12 is 1/3. But what if I think that maybe these two go together and these two go together? If you do 4 over 16, is that equal to 3 over 12? 4 over 16 is 1/4. 3 over 12 is 1/4. And yes, but the difference is how you write your similarity statement. Okay, they are similar, but not A, B, C, and F, E, D. It's actually the opposite of that. So they are similar by side, angle, side similarity. And but the way you write your similarity statement is going to differ. See, here we start with triangle ABC. And that's similar to triangle, see, the 3 goes with the 12. So now it's going to be D, E, F. So the triangles are not turned the same way, which is okay, they can still be similar. Now, it won't work if when you cross those that it works, but if they're still not proportional, then the triangles are just not similar. And that's side, angle, side similarity, and that's the embarrassing.